are you doing?
I'm waiting for time that I told him to get back, and then I'm going to start. They're all that. These are all the students.
What's the first music? Can you tell me all the names?
They're not muted. No. Because I got to start here soon. Well, they can hear you.
Do we have a guest speaker?
Yes, this is Tiffany.
Hi, Tiffany.
She was waving.
I don't know that I can turn on my video.
No.
Hi.
See?
How old are you, Tiffany?
3.
How old are you?
All right, you're a big girl.
I gotta start.
The fantastic dividends of online learning.
This is true. Absolutely true.
Oh,
I think we have just about everybody else. Ooh. So we're pretty close to the time. So let's go ahead and get started. We've got a lot to get done with this afternoon. So we left off and we're going to start going into engine starting. Okay, so we'll go through that. And then just a little bit of the thrust reversers, not a whole lot different with the thrust reversers. So engine starting. So the LEAP engine is different as far as the starting is concerned. And the reason why is because of the bowed rotor motoring side, okay? You have to go through, and you will go through a bowed rotoring motor portion each and every time you do a ground start, okay? Each and every time you do a ground start. You don't do a bowed rotor motoring in flight start. You probably once get the engine started, on that side. Basically, we have the AMM says that there's essentially 4 options for starting the engine. We have the normal start, and that's the typical start that you are going to be doing all the time. Starting air pressure is going to be supplied by the APU. Now, the reason why it's supplied by the APU is because the EECs can control the APU, essentially. They'll control the IGVs, and they'll also control the starter air valve. So they're controlling the amount of air that's going into the engine at that side. Okay. We have a manual override of the starter air valve. The manual override is used to start the engine in case of a starter air valve is unresponsive to your start switch command. Okay. So on that particular case, once again, it depends upon what your air source is going to be on whether or not you have to do anything different. If it's the APU, you still have to, you're following the AMM. The AMM is going to have you do certain things, but since it can control a little bit of the APU, where it'll be a little bit easier. But you'll probably be doing a start function out of the special function side of things. Okay. The other thing you have to make sure that you're careful of with manual override is, remember the valve or the port that you're going to be using to wrench the valve open or close is in front of the red line. Okay, so you're going to have to make sure that your safety harness is on and other type of thing. You need to make sure you follow all the warnings and cautions associated with that. The other one, engine cross bleed start. You're using the engine, the air pressure from the offset engine to start the engine, and a ground start. Okay, ground start cart. You're using the air pressure started using from the ground cart side of things. Okay, so you have those type of things have to go on. So if we look at how the EEC controls everything on a normal start, okay, so remember the EECs control the starter, it controls the ignition, and it controls the fuel. And under normal operation, or a normal start, DEC can make corrections in case of various things, such as a hot start, or an over temp start, or a hung start, or no light off, those kind of things. So it can make corrections for those things, and it's looking at it. So the EEC's pretty smart in that case. So if we look at our components in the starting means, what we have, of course, is our engine start switches. We have our ignition selection and then the engine start switches themselves. We have the engine electronic controls, channels A and B, the air turbine starter and our starter air valve, the APU engine electronic control unit, the DPC, and the engine indication display. So if we look at this, and let's just look at what happens in a sequence of events with the system. So we have ignition selection, either left, right, or both igniters are selected. That information is supplied to the DPCs. The start switch, when I move it to the ground position, that start position is going to go to the DPCs, okay? So now the DPCs know that we are what igniter and that we're going to start the engine. The DPC is going to also select or to apply a hold on the start switches, so it's going to stay in the ground position. The DPC is going to supply the start and ignition switch positions to the engine electronic controls. The engine electronic control then is going to supply input to my starter air valve to open the starter air valve. Okay. It also, when I moved my ground switch here, that also would have put a main engine starting mode of operation into the APU ECU. But the engine electronic controls is now also going to supply a bowed rotor starting APU IGV schedule into the APU ECU. So it's going to control or modify the IGVs. We're also now supplying that information, the bowed rotor system motoring, from the EEC over to the DPCs. We're going to give it the starter air valve position, that information into it. So now the DPCs then are also at this point in time going to cause the start valve light to be open, and it's going to display the motoring signal, okay? So when I open my starter air valve, what's happening is we're allowing air pressure from the pneumatic system to come in through the valve into the air turbine starter, starting to rotate the turbine, which in turn rotates the N2 RPM. And we're going to bring it all the way up to 18%, between 18 and 23%. Okay, we get that motoring signal, and like I said, the start valve open is at that point. Now what's happening is the engine electronic control is using the IGV scheduling and the starter air valve to maintain a 23% N2 RPM, okay? So it's maintaining that. It's going to keep maintaining that until it senses the bowed, that there's no longer a bowed rotor, okay? Once it is gone, then what it's going to do is it's going to inform the DPC. The DPC is going to remove the motoring signal. The EEC is going to remove the mode rotary APU IGV scheduling mode, and now it's going to indicate to the starter air valve to go to the full open position, and the air turbine is going to now bring the engine up to its full motoring RPM. At that point in time, you're going to, once the motoring has gone away and we're up at our full motoring position, now what happens is that you can move your start levers to the idle position. Idle position now then allows start and ignition, or fuel and ignition now to happen. Okay, we're going to get light after the EEC does its test. We're going to get light off, and now the engine's going to go all the way up to its 63% N2 RPM. And at that point in time, we're going to, the DPC is going to remove our start switch hold, and the start switch is going to move from the guard back to the auto position, ground back to the auto position. Okay, and then the starter air valve is also going to be commanded closed. The main engine starting mode is going to be removed from the APU, and the engine's up at that stable idle piece. So that's essentially what is happening during a normal engine start. Okay, and once again, it's going to keep that way every single ground start. Okay, and if you have to do it slightly different, then you need to make sure that you follow the AMM procedures to do that. Okay. The starter air valve is going to be located. It's on the air turbine starter. Okay. It's going to be access port is going to be on the left side of the engine. You have the starter override access hole. And you have a caution there stenciled in there. Start system must be pressurized during the manual operation. It has to be operated, or you have to have the pneumatic pressure there, because if you try to rotate that valve without pressure, you're going to damage the valve, and then you wind up having to remove and replace it. Okay, so damage to everything could happen if you don't do that. Once again, notice that you are in front of your red line. You're in front of the red line, the danger area. Here's your red line right here. Okay, make sure that you have positive communications with the individual who is running the engine, okay, on that side, whether or not it's the pilot or a technician. Make sure you have that before you do this, okay? The starter motor, the air turbine starter, same motor that you have, same starter that we have on the CFM. Okay, it's an air turbine. It's a single stage actual flow turbine air motor. It has a single port for your drain and fill plug, and it's a magnetic plug. Once you install it, you service it, and then it's going to share its oil system with the accessory gearbox, and there's no sight glass to it. The other time that you should probably check it is if you're installing an engine with the starter already installed. You probably would want to go ahead and check it just in case. Okay. Sometimes those have been deleted of its oil, so just check in case. Better be safe than sorry on that. Okay. We look at the engine starting sequence, or our starting pieces. What you have is our battery bus. You have the engine number 1 start switch, okay, ground, off, control, and flight. The DPCs 1 and 2. The APU, EECs A and B, starter air valve, and then the air turbine starter. In the engine start switch, you have the 4 positions of your start switch. Well, each one of those switch positions are indicated into the DPCs, okay, and the DPCs are going to do something with those as you go through. If you place it into the ground position, that then also is going to cause that hold to energize our solenoid to hold that switch in that ground position. And then when it de-energizes, that's removed so that it can spring load back to the off/auto position. Also, when you do the ground position, notice that we're providing that input into the APU ECU for our main engine start sequence, okay, mode. This information is all being supplied to the two engine electronic controls. Two engine electronic controls are then also going to supply an IGV schedule to the APU. And it's also getting switch position and the start switch release from the DPCs. And now we're also going to control the solenoid. EEC-A controls solenoid A. Solenoid B is controlled by EEC-B. Okay, just fall back. So what happens is when we're in this mode of operation with the bowed rotor, what they're actually able to do is it's going to provide a on-off signal to the solenoid, which in fact is going to modulate the starter air valve. So that's how it's going to control that airflow into the air turbine starter to maintain that 23% engine RPM. It's also providing a bowed rotor schedule essentially into the APUs for assistance in there. Okay, so you have all of that. Position of the starter air valve is relayed back to the engine electronic controls so that we know exactly where the starter air valve is, and that information is also then supplied to the TBC so that it can indicate that on our panels. Okay, so that's really just that piece of it. The bowed rotor motoring, okay. Essentially, bowed rotor is, all jet engines have it really, but what it occurs due to a heat soak in the engine after shutdown. So your rotor, one side of it's going to be hotter than the other on that piece, and the rotor just bows as a natural course, okay? And so the higher parts of the engine rotor retain more heat than the lower part. Heat rises, and so that's what causes the bow, okay? Where's mine? Okay. So all of the, so your distribution of heat causes that. Now this can happen or can start to form less than 30 minutes after an engine stops. And it can stay around for greater than 8 hours after the engine starts, okay? So if we look at what's happening inside the this is where the logic is. And the start, so the input into the logic, start lever position, okay? Compressor discharge temperature, your T3, vibration from your turbine case, your N2 RPM, and then the start switch is in the ground position. Okay, the start lever in ground position is going to provide that command for the starter air valve. And start lever position is going to provide an inhibit along with this piece here for our fuel metering and ignition system. Okay? So what we're looking at logic-wise is vibration within limit? Are we less than 86 seconds? And actually, I think this has been bumped up to 90 seconds now. I was talking to a CFM rep, and he said that was bumped up to 90. And then what we're going to be looking at is how long has the engine been off, and what is the temperature of our T3, okay? So it's going to look at all that, and it's going to output a signal to modulate our starter air valve. So that input in here, we've already told the starter air valve that it's going to open. Now we're telling it, okay, modulate. And now we're going to control that N2 RPM to 23% N2 RPM. We're providing a signal to the DPCs. That's going to give us our motoring signal. We're supplying a signal into the APU-IGV scheduling to assist in maintaining that 23%. And then we're providing an additional that inhibit into our fuel metering and ignition system side of things, okay, to make sure that we don't have fuel or ignition. Once everything becomes within limits, then we remove the modulation signal, command the SAV to go to the full open position. We remove the motoring signal. The IGV schedule goes back. The main engine starting signal goes away. The IGVs go back to the normal piece. And we remove the inhibits so that we can start having ignition and fuel at that point. Okay? That's all what the EECs are doing. If we look at graphically what's happening with the engine at this point then is start switch to ground. We open up the starter air valve. Engine's going to, N2 RPM is going to go on up to 18%. And then we get our motoring message. And then we're going to maintain 23% N2 RPM right here. And that's going to last anywhere from 6 to 90 seconds roughly. Typically what's going to happen in the morning or if the engine hasn't been ran for a while, there's not going to have a bowed rotor, so you're going to be right about that 6-second time frame. As you do multiple starts during the day, the engine is going to get hotter, and that's when you're going to start seeing the longer time to start the engine. Okay? So it can take, like I said, up to about 90 seconds. Once we go through this piece, the motoring signal goes away, and then what's going to happen is we'll be able to go on up to our max motoring speed. Max motoring speed is essentially defined as N2 RPM is no longer increasing during a 5-second period, okay? Where you're at is probably right around 25 to 30% N2 RPM. That portion, you're going to see N1 rotation and your motoring portion has been blank. Okay? So at this point, I can now move the start lever to idle. We're going to pre-fill the manifold. And now we're going to do the EOS and TCMA test where we're going to cause the HPSOV valve to go closed and then back open. The EEC is making sure that it can control that. So all of this is about 10 seconds. Okay? Then we'll have fuel and ignition commands are going to go on. We should have light off. And then the N2 RPM is going to accelerate on up to about 63%. At 63% N2 RPM, the switch is, our engine start switch is going to move to the cutoff or to the off auto position. If it doesn't, you need to move it for it. And then it's going to continue on up to stable idle. Stable idle is when the engine start limit red line is no longer shown. Once that is shown, you are now at stable idle. So that's our starting portion of that. Okay. So the controls and everything that you're going to see essentially is our start levers, our indication, start lever opening, the motoring portion, N1, N2 and N1 RPM, oil quantity, and oil pressures are supposed to come up as you start. So all of those things that you can see right there. One thing that just another piece for those of you who actually run the engines, if you're doing an engine run from from the APU or from the cross-engine start and you wanted to watch the pneumatic ducts, how much pressure is in your pneumatic ducts. In some cases, you're supposed to look at that. Well, what you're used to on the NG is looking up at the P5 panel to your pneumatic gauge. Okay, well, what you can do also is bring up your data, your air supply data page that has that more accurate indication and put it on the display on your OMF, so you have everything right there next to each other, so you can keep an eye on the engine and you have the engine, the air pressure right there next to you also. Okay, it makes life a little bit easier. The thrust reversers. Thrust reversers for between the CFM and the LEAP engine, pretty much exactly the same. The LEAP engine has the 3 actuators, but on the LEAP engine, we're going to have a lock on the middle actuator, which you don't have on the CFM engine. And we have the same lock in LVDT on the upper actuator and then the sync lock on the bottom one, okay? Other than that, the reversers work essentially the same. If you look right here, let me get to a piece. So if you look at it, the upper actuator, you have the LVDT and your lock on the actuator. The center one on the LEAP has a lock, so this information is going to be controlled by the EECs. And then your sync lock, controlled by the EEC. The LVDT, just like it does on the CFM, is going to provide the position indication to the EEC so we know the position of the thrust reverser. Indication-wise, you have up in the pylon, you have a stow pressure switch. Okay, the stow pressure switch, of course, is indicating to the EEC that we have pressure when it's supposed to have pressure or pressure when we're not supposed to have pressure. Okay? The indications that we have on the displays, you have the reverser command. Reverser command, of course, is, just a moment. Reverser command, of course, is when we're getting a signal in flight when we're not supposed to for the command. Okay. Reverser limited, of course, your thrust reverser is not fully functional, and if you have a reverser air ground, then you have no air ground data available. Okay, indication for the pilots. Reverse. The amber reverse and the green reverse, essentially amber, of course, just like it is on the NG. The thrust reverser is in transit. Green is in its deployed position. Okay, it's in agreement there. The pressure switch here, it's looking at 750 psi of pressure nominally, and then we have a status message potentially for the reverser if something is wrong, so we have a status message that tells if we have a problem, which of course would then give us our maintenance light and also the reverser limited side. Other indications that you have on your electronic propulsion control system page, you have the thrust reverser sleeves indication. Okay, so you have that. Also, your engine control lights if you have problems there. If you have access to My Boeing Fleet and your AMMs up on the My Boeing Fleet portion or up in the toolbox, there should be some videos that are available to you. One of the videos I would highly encourage you to watch, and that is the thrust reverser operational check. Okay? Part of the thrust reverser operational check is using your displays, the electronic propulsion control system display, and also using the portable maintenance device and using the special function of the engine, okay, in that side. Okay. Part of that test is looking and watching your sleeves deploy. Okay, so I highly encourage you to watch that presentation, and then also then make sure that you follow the AMM on those on that operation. Okay, it's the video helps to make it clear what you're supposed to do as you're going through that. Okay, so that video is up in the My Boeing Fleet, up in the AMM section. If you open up the table of contents on your AMMs, there should be a line item that says supplemental data, and within that would be videos. Okay? And that's the power plant. Okay. So the rest of this afternoon, what we're going to look at is going to be the hydraulics, the flight controls, and the landing gear. And then we're going to look into the pneumatic system and some of the air conditioning. And that. So that will take us up to the end of the day. Okay. Hydraulic system. The hydraulic system, there's not a lot of change. In fact, there's really no change in the hydraulic system between the NG and the MAX. On the standby system, there's another transducer that goes to the digital flight data recorder. It's located right next to the reservoir for the standby system. But your newer NGs also have that same standby transducer. And all it is it's telling the digital flight data recorder that standby system has pressure, if you will. The other things that are going to change, essentially, the users have a little bit of change in them. The flight spoilers and the ground spoilers, obviously, since they are a fly-by-wire system, they're going to be changed, but we use the same hydraulics to help control those. So we'll look at it. So like I said, there's not really any change as far as hydraulics are concerned. Landing gear. The landing gear. Excuse me, I had to take a drink of water down my throat here. My throat doesn't dry out. The landing gear, the main gear, there's really no difference except that size-wise or the strength of them are more, if you have a 900 ER in your fleet, it's going to be more like your 900 ERs, okay? The nose landing gear and doors, obviously those are different. The nose landing gear is taller, and that's really so that we don't drag the engine through the pavement, okay, on that. So the nose landing gear is taller, and consequently the doors had to be changed. So the nose gear is going to be a little bit longer. And if you look at the gear side by side with the NG, the trunnion on the MAX looks more like a V versus the NG, which is more like a T shape, if you will. But that's just so that we can get the height in the nose landing gear. The extension and retraction, it's the control of the extension and retraction of the landing gear that is different. We're going to control that electrically rather than a mechanical linkage, so we'll look at that. Nose wheel steering is the same. The difference that we have in nose wheel steering is there's a broken cable compensator, and all that is a mechanical device to remove the steering input if a cable fails. The tail skid, depending on what model of airplane you have, if you have a -7, you have no tail skid. If you have a -8, it's an option. Depends on where you're flying into normally. And if you have a -9 or a -10, then the 10 tail skid, the 2-position tail skid is a standard. On the 8, the 2-position tail skid is optional. You're either going to have the normal tail skid or a 2-position tail skid on that. So we'll talk more about tail skid in a little bit. Your landing gear, the control of everything. What we're looking at is the same hydraulic system. System A for normal operation of the extension and retraction of the gear. System B is the backup for retraction only. Okay. Transfer valve. Transfer valve is located on the keel beam in the main wheel well. It's the same transfer valve that you have on the NG. The selector valve is different. The selector valve on the NG is a smaller valve, and it's mechanically controlled. It's mechanically connected through a cable to the landing gear lever. Okay? When you move the landing gear lever up, down, and off, you are mechanically moving a slide valve. On the MAX, on the landing gear lever that has only an up and a down position, and it's an electrical signal to either the PSEU or to the solenoids inside the selector valve, and we're going to electrically control it to go up or down or off. The position lights, the auxiliary landing gear position lights and the landing gear position lights on the landing gear panel work exactly the same as they do on the NG. Okay. The PSEU is a different PSEU from the NG. There is no front face bight on it. System 1 electrical connectors on the top. System 2 connectors on the bottom. The landing gear panel, you have the 2-position landing gear lever. It's either up or down. There is no off position on it. Okay. That doesn't mean that we don't have an off condition. Off meaning we remove hydraulics from the landing gear, but that off position is going to be controlled by the PSEU. Landing gear override button, and then your nose wheel steering switch, your alternate nose wheel steering switch. The proximity switches on the landing gears, same switches, same locations, do exactly the same things they did on the NG. The manual extension mechanism works exactly the same as it does on the NG. You're mechanically connected to the locks, the unlock positions on each of the gears, and you have a micro switch that is in the door that's sensing the door position, that when the door is open, it's going to energize a solenoid inside the selector valve. The data page or status page that we have for the system, you're going to have status messages for the gear handle and control, status message for the PSEU. You have a special status message here that is for the air-ground override enable, so that tells you that you have put the airplane into an override enable. We'll look at that in a moment. Main landing gear sensors, your gear warning, and then if you have a system, a tire pressure system or tire temperature system, you could have a couple messages for that. There are a few scheduled maintenance task messages for the landing gear and the PSU side. Okay, not me. I think it's only those three right there. The most task messages are going to come from the pneumatic system, and we'll look at that in a moment. Okay? The data page for your landing gear and the PSEU, just a large amount of data for you. Okay, there are 2 pages of the PSEU data page. On the PSEU, on first page, you're looking at air ground. It's going to tell you, is the PSEU system 1 or system 2, is it in the ground or on the air? If you are simulating air-ground mode of operation, you would have an additional word right here that would say SIM, S-I-M. So if you were simulating air mode, you'd have air sim. If you're simulating ground mode, it would be ground sim. Okay? The landing gear lever, since it's an electrical component now, it's going to provide that input into the PSEUs, and it's going to tell you if it's not up or down in that position, in that area. Auto off is the same thing as your NG, except you're on the NG, it's mechanically, you move the landing gear lever to the off position. Off position in your NG removes the hydraulic pressure when the gear is up and locked. It removes the hydraulic pressure there, and the gear just hangs in the locks at that point. We do the same thing with the MAX, except we do it electrically. And that's going to be called auto off. And the data page can tell you whether or not it's engaged or not engaged. This whole page right here, this bottom portion, is typically referred to as the rigging aid. It's going to give you the position or the all your prox sensors on the nose gear, your main landing gear, and the doors. Okay? It gives you the target right here, so the range for those items. This range takes the place of the goal post that you had on the NG PSEU. Okay? So on the NG, the only thing you can do is one at a time. Here you have all the information available to you, and like Alan said yesterday, it gives you the state and the mills that system is sensing, and then, like I said, the range area. Page 2 provides you with your takeoff information, takeoff configuration. So it's giving you your speed brake information, parking brake, your stab trim, your leading edge flaps, and the trailing edge flaps A and B, whether or not they're in their position. Takeoff configuration horn, it's going to give you that component, what caused the horn to come off, what component, okay? Landing gear hydraulic transfer, this is your landing gear hydraulic transfer valve, the one that's on the kill beam. There are only 2 things that cause that valve to transfer from A system to B system. It's either your left engine out on takeoff or alternate nose wheel steering has been turned on. So it's going to tell you which caused the last transfer. The I/O matrix, the input-output matrix, is going to tell you the pin status of all the electrical connectors on the PSEU. Okay? So it's going to tell you the pin status of each of these connectors on the PSEU. So you have so it has 61 pins in it. So PSEU1 pin number or connector D11138, 1 through the numbers, and then it continues on down. The first one, so here's your P38, and then the rest of the connectors on that. So why is that important to you? Well, you're going to be looking like when you remove and replace the landing gear lever now. One of the things that the AMM is going to tell you to do after you replace it is to call up this page, and it's going to have you move the handle, and it's going to tell you to watch for the pin number, the pin changing from a 1 to a 0, okay, depending on what it's supposed to do. So that's what you're using this for. If you were on the NG, what you'd have to do is actually go down to the byte or to and actually look at down that connector there. So this has everything for you. So a lot of good information. Servicing the nose gear, same as you have on the NG, same steps, okay? So that's really no different on that. The control, we were already talking about it, but control-wise, what we're looking at is your landing gear control lever module, the landing gear selector valve, and the PSEU, and then your transfer valve. Your landing gear lever, it's either up or down. When it's in the down position, what it's doing is energizing directly. It's a direct connection to the solenoids in your landing gear selector valve, and it's energizing the down solenoids. Down meaning extend. When I place the landing gear lever to the up position, that's an input into the PSEU, and then the PSEU is going to energize the up solenoid or the retract solenoid. Okay? Once the gear is fully up and locked, then the PSEU is going to remove this power to the up solenoid, and it does that 10 seconds after the gear is up and locked. The last gear is up and locked. And that's going to be exactly the same as if on the NG if you move the landing gear lever to the off position. Okay? So that removes the power to the up solenoid, and then inside the PSEU, essentially it's going to tell you on the auto off position, it would be engaged at that point in time. Left engine input. If the left engine fails on takeoff, that's an input to the PSEU, and the PSEU then is automatically going to cause the transfer valve to transfer from hydraulic system A to hydraulic system B. Exactly the same as the NG. It does that, of course, because what we lost when the left engine failed, we lost the left engine-driven hydraulic pump, okay, the high volume. We did not lose hydraulic system A, we just lost the high volume pump portion of that. The electric pump could still retract it, but it would take about 2 days to do so. Okay, so what we're going to do is automatically switch it over to hydraulic system B, where the right engine hydraulic system B engine-driven pump is still going, and we can use that high volume then to get that gear up and locked so that we're out of danger at that point. That works the same as the NG. So, right? We look at our landing gear control handle, landing gear lever. Like I said, it's 2 positions, up and down. We have the lock override button. This lock override on the NG was that trigger that was on the lever. Okay. If we look at the insides of the control lever module, we have the landing gear control lever, We have a sliding carriage. We have the up switch assemblies, the down switch assemblies. We have the lock override button, and then the lever lock solenoid. Okay? Normal operation with the lever lock solenoid is on takeoff, the solenoid is going to be energized and it would pull the lock up so that it's no longer locking my lever. If for some reason that failed, I could push the lever lock override button, which would mechanically push that up out of the way so that then I can move my lever to the up position. Okay? When I move my lever to the up position, that's going to take my sliding carriage, moves it to the left, and what that's going to do is cause these switches to go closed and these switches to go open. It's going to activate those items and cause my up solenoids to be energized. So let's just look at these switches for a moment. So those switches, this is the up switch portion. These are the down switch portions right here. And there's 5 switches in each of the assemblies. And if you look at this, we have your up 1 power going to system 1. You have the down power and down ground coming into our down solenoids down through here. You have the same thing down in the bottom, or your down switch assembly. So the lever is controlling directly my down solenoid. The up solenoids are controlled by system 1 and system 2 based upon input into the PSU from the lever. So the PSU is going to control the energizing of the up solenoids, and when we are up and locked for 10 seconds in flight, then the PSU is going to de-energize the up solenoids for auto off position. Okay? One thing I want to point out here is that in this simplified diagram, if you just look at this one here where I'm showing down 1 power coming down through here, this actually has a input going into the PSEU, okay? Because the PSEU is monitoring this. If we jump back here for a minute, you can see here we had the landing gear lever down power, down ground, and the up position, system 1 and system 2. That's what you're looking at here. That's what you're looking at through these switches, this piece right here. Okay? Landing gear selector valve, it's going to be located in the main wheel well, left side, up on the ceiling, pretty much exactly where the selector valve is on the NG. Just be careful, it's a much bigger valve than the one that's on the NG. This weighs about 60 pounds, so if it slips and hits you in the head, you'll know it. Okay, so just be careful there. The nose gear, the manual extension of the nose gear, it works exactly the same as the NG. The only difference between the two is because the nose gear is longer, we had to reposition some things up on the ceiling. So, and that also meant that this link right here had to be redesigned. You can see that this one has a curve in it. If you compare this to the NG, it's straight up and down. Okay? It works exactly the same. You have a roller, a release roller. When you pull the handle for your manual extension, you're going to cause the roller to rotate, which is then going to cause the roller to hit this piece and unlock the gear. So it just, like I said, it just looks slightly different than the NG. but it works exactly the same. The broken cable compensator. I apologize for this graphic. It's pretty dark. The graphic that you may have in your book may be a little bit lighter, a little bit easier to see. But what you have here is you have this pulley and the opposite pulley where the cable is coming down and pulling on. This is attached to your input lever assembly, the left side, and you have exactly the same thing on the right side. And then you have this linkage that goes across, and there's a roller in between here, okay? We'll look at that in just a moment. And then you have your nose wheel steering lever input piece here, okay? With a pivot point right here, okay? And then your rigging pinhole right there to rig it. So if we look at this, this is just, it's colored portion of it. So what we can see here, this line right here and this line right here represents that input lever assembly. And this is the cable. So that's this piece right here and this cable here. So that's the right cable and your left cable. This is that roller that I pointed out. It's right in the center. The pink piece is the nose wheel steering input lever. That lever is attached to this cam, and then you have the pivot point right here. This cable, and this cable, when it has the same, when it's not broken, it has the same tension on it. It's pulling this roller into the cam. Okay, it's pulling the cam into that roller into the cam, so that when I pull on one side or the other, what's going to happen here, it's going to cause my lever to rotate and provide an input into my steering, so I can steer either left or right. If I break the cable, if I lose the cable, it failed, then it would be like this. If I did that tension there, I'm just pulling that cam, or this roller, outside of the cam, and my input lever is going to say stay straight. Okay? So that's all what that is. It just ensures that we remove the steering input from the system. Okay? Your two-position tail skid. Two-position tail skid, like I said, it is an option on the Dash 8. It's standard on the Dash 9 and standard on the Dash 10. The only difference with the two-position tail skid is going to be the control. On the, if you had a two-position on your NG, then it was controlled by a supplemental PSEU. And on that supplemental PSEU, there was a little toggle switch that you could place into the extend or retract position to test the tail skid. Well, in the, where is it? On the MAX, we're going to go to the onboard maintenance, and it's another function for the PSEU, and you have a tail skid extend and retract, and it's just a special function that we can do the same thing as that toggle switch. We can either extend it or retract it through the PSEU. Okay? So that's the tail skid there. So it's the same there. Air-ground system. The air-ground system, the only difference on the air-ground system that we have is really it's the PSEU. We're still going to have all the position sensors and switches are being supplied into the PSEU. So these are all the proximity sensors from the main gear and the nose gear. All the doors, passenger doors, emergency doors, those doors are all kind of going into the PSEU. And the PSEU then is going to provide us with our air-ground discretes, indication and warning, and our relays. So the rest of the the rest of the systems in the airplane can do what they need to do with that. The PSEU is going to control my landing gear lever latch. This is the override switch. It controls the landing gear transfer valve. Okay. It controls the landing gear selector valve, our up solenoids and auto off. Okay. It's going to provide us with the takeoff warning on that. Okay. And door warning. It's going to control the tail skid. And if we have air stairs installed, it's going to control and provide us with the air stair warning sign. The PSEU, no front face bite, System 1 and System 2 connector. Okay, and remember, you can read the pins on the PSEU data page for the input-output matrix. Air-ground discretes. Air-ground discretes for the system. I'm not going to go through each one of these things, but it does the same things we did with the NG. We have the discretes and sensor inputs, and then we're outputting it for all the various aircraft systems that need to know is the airplane on the ground or in the air, okay, for operation. Status page for the system, the PSU status things, and then we have our PSU air-ground override enable status message. Any one of these status messages, if you have it, is also going to illuminate the maintenance light if you are on the ground. Do we need to pull the breaker for the lever latch for power run? I'm trying to remember. Yes, on that piece. Well, for the when you talk about the lever latch, you're talking about the landing gear lever.
Yes, that's right.
Okay. No, the AMM does not tell you to do that.
Okay, thanks.
You're welcome. The data page, we already looked at the data page, okay? The ground tests for the air-ground system. The ground test for the PSU, you have an operational test and you have LRU replacement tests. Okay, there's 3 total tests in all. The operational tests, what you're testing is the landing gear transfer valve test and the PSU self-test. Okay, this is just basically you're checking the LGTV, see if it's working. Okay. The self-test is really just testing the circuitry inside the PSEU. The LRU replacement test is the PSEU, when you replace the PSEU, this test is the self-test here plus all the inputs going into the PSEU. So in this particular case, what the test is going to tell you to do is to open and close all the doors. It's going to tell you to activate the lever, the landing gear lever. It's going to tell you to go to the engine simulation run so that you can check the flight locks. So the flight locks on the mid emergency doors, the overwing emergency doors. It's going to have you do the brakes. Okay, set the brakes and release them because that's an input into the PSEU. All of those pieces, so it's going to tell you that all of those things. It needs that so that it has that input. If you miss one of those and try to continue to run the test, it's going to fail. Okay, so you have to make sure that we do all of that. The other tests that we have for the system, we have onboard maintenance, other functions, special functions. There are 3, and you select Chapter 32. There are 3 tests: air ground override, tail skid extend, and your reset latches. Okay. Obviously, if you do not have a 2-position tail skid, you do not have the tail skid test on it. Okay. Air ground override portion of it, essentially when you select air ground override, you're going to get into this function, and we'll look at this piece here in just a minute. If you select tail skid extend, you're going to get this special function, and that's just nothing more than selecting extend or retract. And then special functions for reset latches, the PSEU can latch certain faults in the PSEU, and in order to reset the system, sometimes you're going to have to come and reset the latches here. Okay. The air ground override is obviously different from your NG, because on the NG you went to the PSEU in the equipment bay, in the nose wheel equipment bay. Here you're going to go to the onboard function. So you're selecting the onboard maintenance function, and you're selecting the air ground piece, and when you select it, you're going to start the function, okay? When you select start function, then what you're going to do is get this window up. Okay, the information that you're going to receive then is air ground override is not active. You'll see ground on both the systems, and then you're going to select one of these 6 items, okay? I just selected the green, the first one, system 1 and 2 for this purposes. But when you select it, then you're going to hit continue, okay? When you hit continue, then what's going to happen, it's going to come into this page, okay? And what you're going to see is the air ground override is active. System 1 and System 2 is in the air because we asked it to go to the air mode, okay? This menu then is going to be, what you're going to find is that this green piece is still going to be active right here. It's going to be shine here. And the cursor is still going to be here on continue, okay? If you hit continue, since this is still in the green, all you're going to do is just keep it. It's going to stay on this page, okay? No matter how many times you hit continue. So once you are in air ground override, then you come down here to stop function, okay? What stop function does in this case is it closes this window. It just closes that window so you can do other things. You can check to make sure that you're still in air ground override by going to your status messages on your status page. You should see the PSEU air ground override enabled, and you would also see your maintenance enabled status message, because in order to do this, you have to do your P61. And since you have the status messages, you're going to have the maintenance light. And then if you go to the maintenance data page for the PSEU, in that first line, what you're going to see is air sim and air sim, because we had selected both system 1 and 2. If we had selected just system 1 only, this would still be in ground, and this would say air sim, okay? To take it out of air ground override, you would start the function again. You come back to this page, you start the function again. This page is going to come up. because it'll have the reset override piece, okay? And it's going to show you that it's active and it's in air. You're going to select reset override, hit continue, and then it's going to go back to this page where it's not active. It'll be showing on the ground, and then do stop function to get out of the system, okay? And then if you looked at your pages here, this would no longer show SIM. The PSU air ground override enabled status message would be gone. The maintenance enabled would still be on until you turn off the P61 switch. And then the maintenance light would go out if there are no other status messages. Okay? Any questions about that? Parking brake, there is no difference with the parking brake. Okay, there's nothing there. Anti-skid auto brake, there is a slight difference on your MAX airplane. Let me just get to here. Yeah. The normal anti-skid valve, if you compared your NG, if you compared the NG, you have 4 normal anti-skid valves. On the MAX, there's only 2 normal anti-skid valves. Your NGs, if you got an NG that was fairly new, it may have these 2 normal anti-skid valves versus the 4, okay? It just depends. Tail skid is optional on the Dash 8. It is not optional on the Dash 9 or 10, and it's not on the Dash 7. Okay. The normal anti-skid valve, the difference between the MAX and the NG, on the NG, well, let me back up. The normal anti-skid on the MAX, the pressure source, the system pressure going into the valve, is coming off of the line from the hydraulic accumulator, okay? So that means that you have a constant 3,000 psi of pressure to be used by the normal anti-skid valve. On the NG, that pressure was variable. Okay, it did not come off that same line, so you did not have a constant 3,000 psi of pressure. So just it's a better design right there. One other word of caution. The anti-skid auto brake control unit. This box is for the MAX. Does not go on the NG. It also is for the carbon brakes only, and that's because the MAX only has carbon brakes. But if you pull your instruction placards out, what you're going to see is a couple of warnings there. Since your flight spoilers are electronic or electrically controlled, one of the inputs into the spoiler control electronics box is wheel speed. If you're doing a test on the anti-skid auto brake control unit and you're having to spin the main gear, it's possible that you're going to send that wheel speed indication to the spoiler control electronics and potentially cause the spoilers to deploy. So make sure that you follow exactly what the warnings and cautions are for your anti-skid auto brake system. Okay? Flight controls, that brings us into the flight controls areas. Flight controls, really other than the spoilers, haven't changed a whole lot. The rudder hasn't changed. The PCU hasn't changed. What's changed here, and we'll get into this more as I get into the system, but on the NG, we have a rudder limiting authority. And at cruise, when the plane is going to a little bit over 137 knots, we're going to reduce the hydraulic pressure to the PSEU. Okay. And that happens on the MAX also. The difference between the MAX and the NG, however, is the FSEU is going to, which controls that limiting. If I lose either engine on the MAX, either the left engine or the right engine, it's going to remove that limitation and put full hydraulic pressure back available to the PSEU for the rudders, okay, to help control it. The ailerons, because we no longer have the mixed control, that mechanical mixing quadrant in the wheel well, we no longer have the control cables from that going up the right side up to the first officer's control column. So that whole portion has changed. The ailerons, how the ailerons actually work and controls and everything is still the same. The spoilers, we have the spoiler control electronics, okay, which is the new computer. Spoiler control electronic is going to get an input from the first officer's control column. There's a transducer mounted onto the bottom of it. So we'll supply that information of that position of the control wheel to the spoiler control electronics. The speed brake lever has a transducer, so we'll supply the position of the speed brake lever to the SCE. Spoiler control electronics is also going to control the auto speed brake actuator. And so the SCE, and then the SCE is also getting a lot of information from various parts we'll look at later. But it controls 8 actuators. These 8 actuators are electrically controlled, hydraulically moved, which controls our flight spoilers. The actuators have LVDTs installed in them, so that's going to provide an input back to the SCE. So the SCE knows exactly where the flight spoilers are, and you'll have that positioning on the flight controls data page when we'll look at it. The SCE also controls the ground spoilers. There's a new valve called a ground spoiler control module, and that's going to control the 6 actuators on the ground spoilers and control the 4 ground spoiler panels. Okay. Trailing edge flaps, no difference really in the trailing edge flaps. The only difference, it's really not a difference, but short field performance on the MAX is, every MAX has short field performance. So on your NG, if you had short field performance, you saw that the flap load relief function worked over a larger span of movement than non-short field, okay? When you change out a flight spoiler actuator, where do you rig the actuator? Well, I'll answer that, Albert, when I actually get into the spoilers, okay? So so really with the flaps, really not a big difference in that area there. Okay, it operates exactly. The elevator fuel and the elevator system, the elevator fuel and centering unit, the elevator fuel and the computer, the elevator fuel computer for the system is essentially the same computer that is on the 900ER if you have a 900ER in your fleet. If you do not have a 900ER, the computer, the elevator fuel computer, works a little bit differently than the other airplanes. And we'll talk more about that when I get into the elevator. Horizontal stab, the electric motor is different on the on the stab, this motor. It's not backwards compatible to the NG. Essentially, the biggest difference with the electric motor is power is going to be applied to it 100% of the time, and then through software controlled by the trim switches, it will use whatever it needs to drive the gearbox. On the NG, power was not applied to the motor 100% of the time. It was only applied when you basically moved your trim switches on your control column. Okay, so that's the biggest difference there. Indications on the flight compartment. Up in the P5 panel, we have a new light, the spoiler panel, the spoiler's light. Okay, all that's doing is indicating to the pilots that something is wrong with their spoiler, with their flight spoilers. Okay, they may or may not have any use of it. The flight spoiler switches, the hydraulic switches, typically used for maintenance. This switch also has an input into the spoiler control electronics, and really it's just a status message. It's telling the SCE that we either have the switches turned on or we have the switches turned off. That's essentially all it is. The leading edge devices annunciator panel, no difference between your NG, works exactly the same. There is a new panel up on the P5 panel. It's the elevator jam landing assist panel. It's also where the maintenance light is located, but it has two components, the assist on light, amber on light, and a two-position guard switch to the off position. What this panel does, when I place the switch to the on position, that's an input into the SCE, and if I'm up in flight and autopilot is off and a couple other things, the SCE is going to turn on the landing gear landing assist. You get the amber on light. The flight spoilers will rise up and extend to about half position, and then the pilots are able to use, or by either pushing forward or pulling aft on the column, will cause the panels to either extend or retract, allowing us to control the flight level of the plane. They're going to use that if my aft quadrant of the elevator has jammed for some reason. Okay? The speed brake extended, speed brake armed, and speed brake do not arm lights, they work the same way and mean the same thing as your NG. The only difference is that the spoiler control electronics control the lights. Okay, it will control the lights on whether or not it's on or off. The speed brake extended light on the MAX also illuminates in one other condition than what your MAX and what your NG does. Essentially, if your spoilers are extended and if the pilots move the throttles forward to a certain position above, I forget exactly what that position is, but essentially what they're trying to do is go fast while the brakes are extended. The light's going to come on and tell the pilot they're out of configuration. They should either pull the throttles back or retract the spoilers, one of the two. So it's just an indication to the pilots in that sense. Trailing edge flap position indication. It's different only because the DPCs now draw the gauge. Okay, it's no longer an analog gauge. It's a gauge that's being driven by the DPCs. It works exactly the same as it did as an analog gauge. Okay, two needles, left and right, the whole portion. The leading edge flaps transit, leading edge flaps extended, and your load relief lights all work exactly the same. Okay. This panel right here. So Alan went through this quite a bit here. Your assist page portion, so that's all good. The only difference, if you if you have this on your NG, the only real difference between the NG and the MAX then is the flight spoiler one. The sensors on your NG for this was the 4 and 9. Pick off the big going to be standard. I believe it's the takeoff config button is standard on the MAX, but I'm going to have to double check that, Albert. The flight spoilers, like I said, the input on your NG is from panels 4 and 9. On the MAX, they're panels 5 and 8. Okay, the reason why they got changed to 5 and 8 is because 5 and 8 have to be functional on the MAX. Okay, you cannot dispatch the airplane if 5 and 8 are disabled. Okay, so since they have to work all the time, it makes sense that those are the inputs for this indication here. Status messages for the flight controls and that portion of it, you know how to work the maintenance side on that. The flight controls data page. The flight controls data page is quite extensive. You have the captain's control wheel, the first officer's control wheel, column position, and your speed brake lever position. The first officer's control wheel and the speed brake lever position, you also have right here your speed brake lever transducer. Okay, remember on the speed brake lever we have a transducer, channel A, channel B, and channel C. This information, this right here should be an average of this information. And then your control wheel is from your transducer on the first officer's control wheel. Okay, and you have 3 channels there also. 3 channels are there for redundancy. The captain's portion, as far as the control wheel on that port, this captain column force piece. This is from your autopilot selection up on the panel, and then FCCA and FCCB and where it's coming from. This right here is your gear on ground. Now, this is not the same gear on ground that you'd see on the PSU data page, okay? This is an additional piece. If you remember, excuse me, if you remember on your NG, for your ground spoilers operation, you had a cable coming from your right main landing gear going to the spoiler control valve, okay, in the right main wheel well area. When you landed and the gear retracted compressed about 3 inches, that would pull that cable and allow hydraulic fluid to go to the ground spoilers piece to extend them automatically. So that happened right away. On the MAX, we do not have that cable. We don't have that cable, okay? But we still need to have that almost instantaneous information for the spoilers to extend almost immediately. So what happens is these 4 signals, your left main landing gear and your right main landing gear, is an input to the spoiler control electronics. And what it does, what this signal goes, it goes straight through the PSEU to the SCE. Okay, there is no logic from the PSEU applied to that, so it just basically goes straight through. So we're going to use that signal there instead of that cable to help control the spoiler, the ground spoiler. The leading edge slats and flaps, you have all the information for the position of those devices. Your trailing edge flaps, left and right, from the FSEU, the FCC, and the SMID, right here. Elevator, ailerons, and your stabilizer. And then your flight spoilers. Your flight spoilers right there. Ground spoilers, this pressure is the pressure that's going from the ground spoiler ground control module out to the panels. And then we also have a cabin pressure sense. This indication is either going to be high or it's going to be low. Okay? It's going to be high or it's going to be low. You're probably wondering, well, why do I have cabin pressure in flight controls? Well, if you have a rapid decompression, what's going to happen on the MAX is, first of all, the pilots are going to try to get down to 10,000 feet as soon as possible. So one of the things they're going to do is take the speed lever and deploy. They're going to deploy your spoilers. Well, the SCE is also going to say, hey, I know that my cabin pressure I just lost all my cabin pressure. Pilot is moving his speed control hand, the speed brake lever, and I'm up X amount of height up in altitude. So it's going to say, we must have a problem, and it's going to deploy those spoilers further. It's going to give us as far as max amount as possible to help assist in getting the plane down safely to 10,000 feet. Okay? So those are indications. The panels, controls, speed brake lever handle. Speed brake lever, it's the same handle, same position that you have on the placard on that side of it. Inside the control wheel, if you remember on your NG, you had a armed switch that was set by your speed brake lever, and you have an RTO micro switch. The arm switch is no longer there because it's taken over by the transducer. The RTO switch is still there because it works off of the thrust reverser position. Flap lever is the same, stabilizer is the same, indications the gauge is slightly different. Your stabilizer trim cutout switches, those switches are labeled different. You have primary and backup on those switches. On the NG, it was manual and autopilot, okay? On the NG, you had to turn both switches off to remove full power to the motor. On the MAX, these switches are actually, the power is labeled is wired in series. So moving one switch to turn it off is going to do the same as moving both of them. The pilot's directions is to turn both off. Just keep it common with the NG in that regard. Okay. The flight control modules, these are exactly the same as the NGs. Panel switches, all these work exactly the same. Ailerons, like I said, the ailerons are still essentially the same. We already looked at where our aileron information on the flight data page is located. And do you guys want a break? I just noticed that I have been yapping for a long time. All right, let's have a break. So I have 15 minutes after the hour. Let's come back at 10 minutes from now, okay, at 25 after. On rapid decompression, can the SCE deploy the flight spoiler? No. No. It always has to be by command of the pilot, okay? The pilot has to move the speed brake lever, okay? So it will not deploy the spoilers automatically on a rapid decompression. Now, if we're talking about maneuver, not if it's, I forget what the term is, but for removing load alleviation. Thank you. And actually, it's called on the Max. It's called manual load load alleviation. What it's going to do is it's going to raise and lower MLA exactly. Yeah. What it's going to do is raise and lower the panels to remove the pressures on the fuselage or on the wings. You have to remember that on the Max, the wings are different. They're very skinny out towards the far end. And if I'm in a move or a turn, and I have panels are raised up, I may have to, and I'm in a move that would cause damage to those tips. I'm going to lower the panels probably on one side or the other to relieve that pressure. It's also looking for the same thing on the aft fuselage. If I'm in a maneuver that's going to cause damage to the aft fuselage, what we're going to do is we're going to automatically move those. So yes, that's automatic.